In machine learning, a data set is fed to the is fed to a model which is known as machine learning model, and this model predicts the pattern, or mainly it predicts the trend, predicts the trend, and D predicts the trend, right? And also we have seen that based on the type of data, what we do, we apply different types of models. Maybe regression model we apply, or classification model we apply, this way. And based on the model applied, either it will give some classification, pattern of classification, or it will give some pattern or some concrete, it is called deterministic value of the predicted parameter. And the predicted parameter is called the target parameter or target variable, target variable, and it gives the predicted value so that we can analyze the future trend. Analyze the future trend. Right? And when we predict, or we find, when we derive the predicted value of the target variable, then two things are very important. One is some values are computed from the data set. Some values are computed from the data set, and some values we provide externally. For example, suppose that we are using a regression model. In that case, from the given data, we compute mean, median, or standard deviations, right? And similarly, if you consider another example, like say we are applying, say KNN, K nearest neighbor model. This is a classification model. And in this model, what this model will do, it will compute the distance of the new point or data point, distance of the new data points to the k nearest points, or k neighbors, better we can say. It will compute the distance to k neighbors which is very close to itself. For example, so this is a data set. We have x value, x1 value, we have x2 value, and we have a target variable y. Suppose if x1 is 6, it is 7, then it is 1. If it is 3, it is 2, then it is 0. If it is 8, if it is 9, then it is 1. If it is 5 and it is 8, then it is also 1. And let us take few more points. Say 4 and 3, this is 0. It's a classification problem, and there are two classes. It's a binary classification problem where there are 1 and 0 class. Now what we will do, suppose a new point is given to you as 6 and 8, 6, 8. You have to determine or predict what will be the class of this newly coming element. Let us say this is 6 and 8. We need to find what will be the value here. So what we will do here, it uses the concept of distance between 2 points. The points are x1, y1. The points are 6, 7. Second point is 3, 2. Third point is 8, 9. Fourth point is 5, 8. And the last point is 4, 3. And the new point is 6, 8. And we will find this distance, not this one. We will find the distance, say d1, distance d2, distance d3, distance d4, and distance d5. How to compute this distance? Let us say d1 is equals to square root of x1 minus x2, means 6 minus 6 whole square plus 8 minus 7 whole square, which is equals to, this is 0, 1, so it is 1. Then d2 is equals to square root of 6 minus 3 whole square plus 8 minus 2 whole square, which is equals to square root of 6 minus 3, 9 plus 36. 9 plus 36, 36, which is equal to square root of 45. d3 is equals to 6 minus 8 whole square plus 8 minus 9 whole square, which is equals to 8 minus, it is 4, plus 1, which is equals to square root of 5. d4 is equals to square root of 6 minus 5 whole square plus 8 minus 8 whole square, which is equals to square root of 1, which is equals to 1. And last point, d5 equals to d5 1 1 2 3 4. Okay, 4 we have computed. Okay, 4 3 is there. So here 6 minus 4 whole square plus 8 minus 3 whole square, which is equals to square root of 6 minus 4 is 4, 2 square is 4, 8 minus 3 is 5, it is 25, which is equals to 20 square root of 29, right? So this is 1. Square root of 4 5 is how much? Just 1 minute. Four five square root which is 6.7 square root of 5 means 2 point something, right? 2.3 almost, and this is 1, and this is equals to 5, almost 5, and this is 1. So now the new point, what is the new point? New point is 4 3. This is d3. This is not d2, d5, right? d5. This is the distance, d5. New point is 6 8. Sorry, 6 8. New point is 6 8. So this distance is 1. This distance is 1. This distance is 6.7. This distance is d3, which is equals to 2.3. And this distance d4 is equals to 1, and d5, which is equals to almost 5 point something. Now the algorithm is KNN, K nearest neighbor. We will see this point, we will see here 3 nearest neighbor. K, suppose that K, not K equals to 3, K equals to C3. Then we will compare first this 6 point, we'll take first the lowest tree. 1, this is the first lowest, this is the lowest one, this is the second lowest, actually equal, and the third one is d3, right? This is 1, this is 2, this is 3. So this one, oh sorry, this point, right? This point, and the second point is d3, d1, d2 is not done, d3 is okay, d3 is this one, and then d4 is 1 2 3 4. Am I correct? This one, this 3. So K, since K is equals to 3, we will compare the distance from the new point 6 8 to the closest 3 members. These closest 3 members are 0.67, then 0.32, no, not 32, right? Not this one, these two, not 32. Which one? 8 9 and 0.43, 5 8, these 3. Now all this we'll see what is the value of y in all these 3 points. Here it is 1. So if it is 1, then it is supposed to be, this new value should be supposed to be 1. That means it says that the newly coming point, it gives or it falls in the positive class, right? Positive class. Now where is the important point here? Important point, how have you decided the value of k is equals to 3? We could have taken the value of k is equals to 5 also. Two things are happening here. First one value we are computing d1, d2, d3, d4 and d5. And second one we are taking the value k as 3 or 5. Now these values which are computed from the values computed from the data is called model parameter. And values supplied externally is called hyperparameter. These are very important terms that is necessary for modeling any data set. Also, it is important to know and to understand the meaning of these parameters. Model parameters are those parameters which are derived from the data set given. For example, in KNN, the distance, in case of regression models, mean, median, standard deviation, these are all calculated from the given data set. But those parameters which are not designed or which are not derived from the data set, rather it is supplied from outside, is called hyperparameters. For KNN, the value of k is the hyperparameter, because it is supplied to the model by the external user, or it is supplied externally. Similarly, in support vector machine, the values of support vectors are model parameters which are derived from the data set, whereas the C parameter and gamma parameter, these are the hyperparameters. And who decides these hyperparameters? It's a very important question to understand. Normally in a data analysis process, in the process of data analysis, mainly two parties are involved. One is the analyst, data analyst. Second one is the programmer. The analyst, basically it analyze manually or some other means, analyze the data, and that data, based on this analysis, he predicts something, but if he wants to confirm it through some program, it gives to the programmer. This person is actually the expert in the area. And this expert decides those hyperparameters. This expert decides those hyperparameters, and programmers are supposed to take comments or advice from those experts in order to decide, or in order to fit these parameters into the model. So if we do that, then it is likely to be the most powerful prediction and most accurate prediction that can a machine model give to the user or the decision makers.